And I'll write it down for everyone. Okay. So today. And we are looking at P.2 and P.3. These are prerequisites. And we are looking at pages 33 through 34 first. So we're starting with exponents in scientific notation. That's the title of P.2. Exponents and scientific notation. Exponents and scientific notation. And let's review a couple of exponential rules. So for example, if I need to multiply a to the mth power by a to the nth power, can anyone remind us how to proceed? Copy the base. What happens to the exponents? Very good. Excellent. What about when I divide? Very good. I copy the base and I subtract. It's always in the same order. From the exponent of the numerator, I subtract the exponent of the denominator. What about when I raise a base to a 0 power, assuming that a is not 0? It is 1 indeed. Okay, so on page 33, I'm going to pick, actually one more, the power rule. A raised to the mth power and everything raised to the nth power. We copy the base, and then what we do with the exponents. Yes, here we add them, here we subtract them, and here we multiply them. M times n. I'm going to pick 2 problems, and then you can pick another. Let's start with problem 34 on page 33. X to negative 6, everything to the 4th power. And I want to, in view of this, I like to add the negative exponent rule. So we have the sum, the difference, the product. And this is 1. And when I raise a base to a negative exponent, what does that mean? It's a notation. And what does it represent? It's not a negative number. It could be. It could be. But it does not mean that if the exponent is negative, the number is negative. No. It could be, however. So now we are trying to apply all these rules when they are applicable, if they are applicable, to the examples that we choose. So x to negative 6 raised to the power 4. What will you tell me to write? Copy the base.
1 over x to the 6.
Careful. Not yet. No. Very good. Very good question. I would leave this property till the very end. I will not touch it. I will not do anything to it.
A over negative 24.
No, I will copy the base first. And which rule will I apply? Forget about this one for a moment. Which is the only rule that...
The top one.
Right here.
Yeah.
Right. So I copy the base, and what do I do with the exponents?
Multiply.
Very good. So this is negative 24. Now I apply the last rule, which is...
1 over 24.
Exactly. 1 over x to the 24th power, and this is final. Bless you. But you're right. Sometimes I may have to apply the negative power rule first. It depends on the problem. Okay. What about 38? On page 33. Please stop me if you have questions. So 38 on page 33, x to the 10th power divided by x to negative 10. Again, I will not recommend you apply the negative power rule till we fully simplify this expression. So which property applies here, or which rule applies here?
Subtract.
Yes, copy the base, which is x. Just remember, if this is x and this is y, you cannot apply this rule. But they have the same base. Yes, please.
Is x to the third?
Which one?
30, top one.
In the book, it says x to the 30th, not x to the 10th.
Oh, I do that a lot. Keep an eye on me, please. Sorry, forgive me. Good. My mistake. Good. Thank you. So x to the 30 is divided by x to the negative 10. Copy the base. What do I do with the exponents? From the exponent of the numerator, I subtract negative 10. X to the 40th. Very good. Any questions? Any questions before we move on to 61? Okay. Let's say a negative 15, a to the 4th, b squared divided by 5, a to the 10th, b to negative 3, and everything to the 3rd power. What would you like to do first on this problem? If you need more time to copy or if you need me to slow down, you have to let me know. Otherwise, I would like to continue. I mean, I can stand here and smile back to you, but you paid for this class, and I like to show you as much as possible.
You multiply the exponent replacing.
Very good question. I would not deal with this before I fully simplify inside. Because if I have to raise this to the 3rd power, I have 1, 2, 3, 4, 5, 6 factors to raise to the 3rd power. But if I simplify, I will end up with 3, and I will only raise 3 to the 3rd power. Will I get the same answer? Of course. I'll get the same answer. But it will be easier if I simplify first. Always, always simplify. Make it yourself a note. Try to simplify first. Before anything. That's the key. Make your life easier if you can. So now I will simplify because I see what? I see same factors. I lost my red pen. So this and this and this go together. So negative 15 divided by 5 is a to the 4th divided by a to the 10th is a to the, very good, and times b to, very good, and everything to the 3rd. Do we understand the inside? Is this okay? Now, see, instead of raising 6 different factors to the 3rd power, I raise only 3. So let's continue. I'm continuing here. Can you see in the last row? Can you see? Yes? Okay. So I'm raising negative 3 to the 3rd power. What do I get? Negative 3 times negative 3 times negative 3.
27.
But negative. Good. Multiplied by a to negative 6 raised to the 3rd. Copy the base. What do I do with the exponents?
Multiply.
Good. So it's negative 18. Copy the base, multiply the exponents, and then b raised to
15.
Very good. Negative 27 and b to the 15th cannot go anywhere because they have power 1 or positive, in other words. But a to negative 18 will go where?
Bottom.
Very good. And this is it. That's final. In my opinion, we had enough, but it doesn't matter what I think. It matters what you think. Have we had enough from 1 through 64? Or we need another? Yes or no? Are we okay with this? Is this good enough? Okay. So then I'm moving on to my page 2. And let's review the radicals and rational exponents. So this is P3. I will highly recommend read these 2 sections as soon as possible. So in case we forgot something and in case you need more practice, then you fill the gaps quickly. Or ask next time. So P.3, radicals and rational exponents. Radicals and rational exponents. Because I write while standing, sometimes I apologize from the beginning. Sometimes my handwriting is not perfect. It was never perfect, actually. So if there is something you don't understand, please ask me. So radicals and rational exponents. First of all, let's talk a little bit about a radical. So this is the radical symbol. That's the symbol. This number is called index. This quantity is called radicand. Radicand. The radical has a base, this, and it has an exponent, this. Now, here's another note for us. Note, any radical can be written as an exponential notation. And something important follows. This is not finished. Any radical can be written as an exponential notation with a fractional, this is the key word here, exponent. Any radical can be written as an exponential notation, but not as just any exponential notation. A specific type, one which has a fractional exponent. So in other words, what I'm saying to you is this. A to the third is not a radical. A to 2/3 is a radical. Because the exponent is a fraction. If the exponent is a fraction, then that is a radical. If the exponent is not a fraction, then that is not a radical. Yes, please.
Did you have A to 3/1?
Yes, but there is no root with index 1. Excellent question. I have not gotten the chance to explain the index yet. You're correct. So let me mention the index. So index, because he's right. Your colleague says, well, any number can be written as a fraction. I agree. But the index cannot be lower than 2. So it can be 2, 3, 4, and so on and so forth. It cannot be 3.5, or 1, or -3, or 0. Okay, so coming back to our notation. This is the index. It starts with 2 when we don't write it, actually. So the square root is this. We don't put any index in there by convention. But it should be 2. But we don't want to write it. We know it's 2. The cube root. The cube root of 8. So any other index has to be written except 2. And there is nothing lower than 2. So now we come back. I said in my note that any radical can be written as an exponential notation. Can anyone give us the exponential notation that represents this radical? A, yes. To which power?
To the n.
Exactly. So A, oops, let's try. A raised to m over n. M over n. The index is always the denominator. The index will always be the denominator of the power. Now, a couple of very important properties of the radical. So any radical can be written as an exponential notation, but it's mandatory that its exponent is a fraction. And I will say comma here at my note, and vice versa. What does that mean? Any exponential notation that has a fractional exponent can be changed or converted into a radical. If this is not a fraction, then you cannot convert it into a radical. If it is a radical, you will always convert it into an exponential notation, which has a base and a fraction as exponent. Okay, questions? Okay, number 3. Page 3, I meant. Okay, properties. Before we choose problems. These work for any index. Can anyone remind us what to write for the first one? A root of a product. The nth root of A multiplied by the nth root of B. No, this is not a distribution. Yes, as long as it's multiplication. Yes, absolutely. So this is not a distributive law. I'm not distributing the radical or anything like that. I'm just saying the nth root of A times B is the same as the product of the nth root of A times the nth root of B. What do you think about the second one?
A divided by B.
Of course. So this is the nth root of A over the nth root of B. Perfect. What about the last two?
N squared with A plus n squared with B.
Okay, so this was a tricky question. And I'm going to say never. So the nth root of A plus the nth root of B will never equal this, and this will never equal that. So never apply this property for a sum or a difference. When the radicand is a sum or a difference, there is no way of simplifying it. So for example, the square root of x plus y cannot be further simplified. The cube root of x minus y cannot be further simplified. This is it. But if I have, let's say, the cube root of 8 times x cubed, yes, this I can simplify. I can write it as the cube root of 8 multiplied by the cube root of x cubed. What do I get? 2x, indeed. Indeed. But if they were added or subtracted, I would have not been able to do anything. So the cube root of 8 plus x cubed, that's it. You cannot do anything to it. So please remember that. I need this for the distance formula, which we will look at a little bit later, not today. When we get to x squared, let's say, plus y squared. You cannot, I'm not going to even write it. You cannot that this equals, write that equals the square root of x squared plus the square root of y squared. It's not possible. Okay? Now, before we choose problems from this section, on page 48 and 49, I just want to remind you one thing. What is the difference between this? If there is any difference. Are these two different or not?
Yes.
Okay, very good. Can you give me any of the two? Yes.
The one without parentheses does not include it when it means square root,
Okay.
and the other one does include it.
Right. So what will this equal to?
4.
Very good. What will this equal to?
-4.
Indeed, because by the order of operations, you have to square 2. You're not squaring -2. You have to square 2 and then multiply by -1. So these are two totally different situations. Of course, if the power is odd, it's not going to make any difference. So if I have -2 to the third or -2 to the third, because the power is odd, it's going to be the same thing. But when the power is even, it's not going to be the same. So this is 2 to the third, which is 8. 8 times -1 is -8. -2 to the third is -2 times -2 times -2, which is still -8. Is this clear? Yes? Yes?
Yes.
Okay, perfect. On page 48, we're looking at problems 1 through 90. I'd like to start with 10 on page 48. And this is the square root of 144 plus 25. Oh, of course, I copied 8. So 8 on page 48. I would like to write that this is the square root of 144 plus the square root of 25. Is that okay? I'd like to write this. The square root of 144 plus the square root of 25. No, I just said that, right? That's not allowed. As long as the radicand is a sum or a difference, I cannot do that. But I can do this and add 144 to 25, and I get 169, and then the square root of 169 is right? Okay, let's look at problem 16 on the same page. The square root of 125x squared. It's a product. 125x squared is obviously a product, so I can rewrite it as 125 times the square root of x squared. In this problem, I'm told everything is positive, so x is positive. Very important. I'll show you in a minute what happens when x can be any real number. And I will have no problem simplifying this. What is the index? 2. So remember, coming back to this notation, this is 2 and this is 2. So then I have 2 over 2. So it's x, right? What about 125? However, the square root of 125 is not an integer, right? But I can present a perfect square, and something that is not a perfect square that represents 125. A product, of course. Otherwise, I will not be able to simplify if it's not a product. So can anyone give us a product of something that is a perfect square and something that is not, such that when I multiply them, I get 125?
25 and 5.
Very good. Excellent. 25 and 5 is the answer. So then now, this becomes the square root of 25, the square root of 5, and the square root of x squared. I wrote it one more time so we can see what happens here. So then, you already told me that this is x. Now, how much is this?
5.
Good. So how will I write the simplified form? We prefer the radical at the very end. So I will write
5x.
the square root of 5. 5x the square root of 5. Very good. Now, what happens like in 28 on page 48? And we have the square root of 72x cubed divided by the square root of 8x. Now, the previous properties, I'm going back for a second, they go back and forth. So we are given the square root or the cube root or nth root of a product, we can come up with this as well as this way. So if I'm given this, a product of two radicals, if it's a product, I can condense it into, and if they have the same index, of course, I can condense it into the nth root of a times b. The same thing with the ratio. You can go back and forth. So now when I see something like this, and I see common factors, because 72 and 8 have common factors, and x cubed and x have a common factor, I will go backwards, in other words, based on the formula that we looked at, keep it in one radical, simplify it, and then at the end simplify again if there is a need. So 72 and 8, I can simplify it by 8. And x squared, x cubed with x. I take away an x from the bottom, and I take away an x from the top. So I get the simplified form for now is 9x squared. But I know how to further simplify this. Yes, it will be the square root of 9. Of course, you don't have to, you can skip this step. And it is indeed 3x. Okay. I'd like to choose problem, let's say 47. Stop if you have questions. 47 on page 48. Any questions for me? Any questions? Okay, and in 47 we're looking at rationalizing the denominator. This is a very important procedure. So rationalize the denominator. What does that mean? Rationalize the denominator. If a denominator has a radical in it, we call it irrational. Of course, if it's fully simplified, if it's the square root of 4, which is 2, that's not irrational. But the square root of 5 is irrational. It's an irrational number. So in order to rationalize this, I'm interested in getting just 5 in the denominator. And you can say, really? So what?
Multiply by 5.
If I multiply by 5 and the bottom and the top and the bottom, I will not get to 5.
Radical 5 over radical 5.
The square root of 5. So I will have to multiply by the square root of 5 and divide by the square root of 5. This has to be 1. And it is. The square root of 5 over the square root of 5 is 1. So multiplication by 1 does not change the value of the square root of 2 over the square root of 5. But it will change the outlook, the presentation. Now, when I multiply the square root of 5 by the square root of 5, I get the square root of 25, which is 5. Correct? We are multiplying. We cannot add, right? I mean, I could add a square root of 5 to the square root of 5, but it will not make any difference. And we cannot add denominators. That will not be allowed. So when I multiply these two, I get the square root of 25, which is 5. When I multiply these two, I get the square root of 10. And that's the final answer. And you could say, okay, what did you accomplish here? This is a procedure that will come into play later. So it's a very important method. of simplifying radicals or radical expressions. Any questions? Now, when the denominator has more than one term, that's a little bit more difficult procedure. Let's look at, let's say, 54 on 48. So 11 divided by the square root of 7 minus the square root of 3. And before we discuss this, I would like us to make a contract. We're signing it virtually. We imagine that we sign it, but it's still good enough for me. So I would like you to remind me, what does this equal to? And what does, oops, I meant minus. What does this equal to?
A squared plus AB.
Almost. Almost.
Did you multiply by the same thing twice?
Right. But I want the formula directly. I don't want to multiply. But you can if you want to, yes. Correct. I just want the whole thing done.
So square root.
No square roots. Yes, I want the final form.
So A squared plus AB squared
No.
A squared plus
2
2A.
Very good.
plus B.
If you need to remind yourself this, please multiply it, put it side by side, distribute, whatever, and remember the answer from now on. We want to make one step forward and move away from foiling this. Okay? So what about the second one?
A squared minus B squared minus 2AB. Okay.
Very good. And one more. A plus B and A minus B. So this is our contract. So when I say contract, you have to give me these three answers. So we don't waste time. And this is beginning algebra. So we don't want to have to sit down, okay, let me FOIL it again. You can do it, but let's from now on remember this. So how much is A plus B times A minus B?
A minus B.
A squared minus B squared.
Very good.
There you go.
So this is our contract. Okay? Practice, FOIL it, one last time, do whatever you need to do with it, so we don't have to come back to it. So now I need to use one of these three here in the process of eliminating the denominator. Actually, not the denominator, eliminating the radical from the denominator. Okay, so then which of these three you think I'm going to use? Absolutely the last one. Absolutely. So I do have what it's called A minus B. What do I need?
B plus B.
Right, we call that the conjugate. So these two are called conjugates. Conjugates. This is the conjugate of that, and this is the conjugate of this. So then what will you tell me to multiply top and bottom? Not just top or just bottom, because it has to be one.
2 7 plus 2.
Very good. The numerator is easy. Don't do anything to it, just put them side by side. You cannot add the square root of 7 to the square root of 3. There is no reason to distribute 11. This is good enough. But now I would like you to use this formula and give me the final answer for the denominator. In this form first, what will you tell me to write? Yes? Say it louder. I heard it.
7 squared.
It's the square root of 7, which is squared, which is the square root of 49, which is 7.
Plus 3.
Look at the
A
sign.
minus.
Very good. 7 minus 3 indeed. So the simplified form is 11, quantity, the square root of 7 plus the square root of 3 divided by 4, and this is final. Any questions? Any questions? Okay, I'd like to look at problem 57. The cube root of -8. Which number we cube to get -8?
2, 3.
If I write 2, that would not be correct because 2 to the third is not -8. Okay, -2. Very good. So I want to say something about odd indices. If a radical has an odd index, anything goes. Anything goes under. No problem. Friendly. So an odd can have positive, can have negative, can have 0, and the answer will be positive, negative, or 0. So this is a friendly radical. Defined everywhere, no restrictions, no problems. However, the even index, this is not friendly. It can only have positive or 0, and the answer is always positive and 0. So please see the difference, and remember the difference. Now if I look at problem 60 on the same page, the fourth root of -81, what would you say? Exactly, you cannot do it. So I'm going to write not a real number. It's not a real number. Very good. So please remember, odd index, friendly, no problem whatsoever. No restrictions inside, no restrictions outside. However, the even index has restrictions on the radicand. It cannot be anything but positive or 0. And the answer will always be positive or 0. Okay. I'd like to look at one more problem here. Let's say problem 87. They have for us 125 raised to 2/3. And they say evaluate it without a calculator. Fine. I can also show you with a calculator in a second. So how do I do this? Okay. Here's my preference. I look at 125, and I know that 125 is 5 to the third. And now I go back to the exponential rules, in which I copy the base. I copied it. What happens to the exponents? What do I do with the exponents? Multiply them, right? The first exponent is 3/1, and I have to multiply it by 2/3. What do I get?
2/9.
So I get 2/1, right? Or power 2. So the answer is 25. You can say, what about another way? Yeah, there is another way, but I think it's more complicated. To change this into the cube root of 125 squared. If you rewrite it as the cube root of 125 everything squared, then it's easier. Because then you apply the cube root, which is which number I cubed to get 125? 5. So now 5 squared will be 25. And here is the graphing calculator. So you have several options with the graphing calculator. Here's one option. The one that I like is 125 power in parentheses 2 divided by 3 close the parenthesis. Always have parentheses. I highly recommend. I don't know, some calculators may do it without parentheses now, the more sophisticated ones. I recommend to be on the safe side, put the power in parentheses. And press enter. When you press enter, you have to get 25. Yes, you can rewrite it as the cube root, and so on and so forth, and you will get the same thing. Any questions? Any questions? Okay, I'd like us to continue with reviewing section 1.2, which is on linear equations and rational equations. Any questions for me? So 1.2, linear and rational equations. Let's choose a couple on page 118. So let's choose one from 1 to 16. If you don't choose, I will. And then another one from 17 through 30. And then another one from 31 to 56. 118. Page 118. Okay, problem 12. 2 minus, in parentheses, 7x plus 5 equals 13 minus 3x. Can anyone suggest?
Carry on that negative.
So 2, and what should I write?
Negative 7x minus 5.
Excellent. What should I do now? And the answer is I'm not going to move terms around. I will simplify fully on the left-hand side first. So you can write negative 7 minus 3 or negative 3 minus 7x. Doesn't matter. What I recommend now, of course, you stick with your own method if you prefer it. What I like to do, I move 3x to this side and I move negative 3 to this side at the same time. When I move a term from one side to the other, I only need to change its sign. So negative 3x, moving it to the other side will become positive. So negative 7x plus 3x is negative 4x. And I move negative 3 to the other side, it becomes positive. 13 plus 3 is 16. From here, I know what I have to do. What do I have to do? Both sides by negative 4, and I get 4. And that's the final answer. Now, let's look at rational equations. I don't consider myself a rational equation. I don't consider it if it doesn't have x in the denominator. So something like this. X over 2 equals 1/2 plus 3x over 2 or over 4. Like, let's not make it all the same number. I don't consider this a rational equation. It's not rational. It doesn't have x in the denominator. It's still linear. So when we talk about rational equations, we mean something like, let's say, problem 46. And that's my 7, isn't it? Yes. 46. Where are you? 46. Okay, 5. 46 on 118. 5 over x plus 2 plus 3 over x minus 2 equals 12 over x plus 2 times x minus 2. This is indeed a rational equation. It has x in the denominator. If it doesn't have x in the denominator, it's not rational. Okay, so first of all, I'm looking at this fraction, and then I'm looking at this fraction, and then I'm looking at this fraction. And I realize that this fraction will not exist will be undefined when x plus 2 equals? Excellent. Very good. So indeed, x plus 2 could not be 0, which makes x not equal ever what? When I move 2 to the other side, it becomes negative. So negative 2. Now, looking at the second fraction, what will I say? What will I write? That x minus 2 for sure, for this fraction to exist, will not equal 0, which means x will not equal 2. And of course, these two are also here. So if I solve this equation at the end of the day, I get x equals 2. What will you say? Impossible, because I already know that x is not, equals 2 is not accepted. And I will say no solutions, right? So let's see what happens. Here is the method I recommend. You stick with the method you like, however. I want to move this term to the other side, which is a fraction. I move the one term from one side to the other. What happens? What is the only thing that happens when I move whatever from one side to the other? Just the sign in front changes. Now I have to have something left on the other side. When I move this term, this fraction, from the right to the left, what is left on the right?
0.
Yes, if I forget to write the equal symbol and 0, I mess up the whole thing. I'm never going to solve for anything. So if I forget to put the equal symbol and 0, I change the equation to an expression. And that's not what I want to do. Okay, so now I have to find the least common denominator. Look what I do. I draw the long fraction line, the equal symbol and 0, because if I forget the equal symbol and 0, again I will mess the whole problem up. What is the least common denominator?
X plus 2, x minus 2.
Exactly, the two different factors we have. Absolutely, thank you. X plus 2, x minus 2. Well, these two fractions have to multiply the top. I have to multiply the top of those two by something. So x plus 2 was multiplied by what to get this?
X minus 2.
Very good. I'm making myself a note. Don't forget. You multiply the denominator by x minus 2. You have to do the same thing to the top. Now, what about here? X minus 2, x minus 2. What am I multiplying x minus 2 by? What do I have to multiply the top by? Very good. Excellent. Now, can anyone dictate the top?
5x minus
5x minus 10. Excellent. Do you all see 5x minus 10? Now I'm here with plus. Plus what?
10, 3x plus 6
Very good. Now I'm here with minus.
minus 12.
Very good. Excellent. What do I do next? We're almost there. Exactly. Do not attempt to simplify anything. That will be a terrible mistake. So then what do I have left at the top? Indeed. Yes. So here I have the negative 22, right? Minus plus 6 is negative 16 over x plus 2, x minus 2. Do you allow me to write 0 as 0 over 1? Remember we had a discussion half an hour ago? What about 3 over 1, right? Can I write 0 as 0 over 1? Can I write 2 as 2 over 1? 10 as 10 over 1. Okay, very good. So here's what I'm going to do now, because this is a proportion. And this is allowed only in a proportion. What is allowed only in a proportion? Exactly. So let's cross multiply. So how much is 8x minus 16 times 1? 8x minus 16. How much is times 0? Now I have to solve this equation. I'm moving 16 and dividing by 8. I didn't know the answer. I just wrote as an example. So what is the final answer here?
Not a real number.
No. We are going to say something else. But 2 is on the list of restrictions.
Not a solution.
No solutions. The equation has no solutions. Indeed. The equation has no solutions. I have 6:14, so I have to stop. But do you have any questions for me?
All this is reviewed.
All of this is review from a previous course. However, when you go
Reviewed in here, too.
when you go home and you review everything we've done and you read the book, let me just stop.